Okay, today's lesson is multiplying by polynomials 7-2, and we are moving on from addition. Eventually we will cover division as well. Excuse me there. But today's goal is to use the distributive property to multiply polynomials. One of the ways I try to get kids to think about this is the idea of to be fair. All right, so keeping that in mind, let's look back at a couple of things that we've looked at in the past. If I can zoom in here. All right, last chapter we were talking about exponents, and when we take 2x to the fourth times 3x to the fourth, remember that our coefficients, those numbers in front, we're going to multiply those two things together to get 6. And then x to the fourth and x to the fourth, that becomes x to the, we add the exponents, 8. So that's one thing that we've got to remember from last chapter. And then sometimes you're going to be adding things together. And so if I took 2x to the fourth plus 3x to the fourth, I would get 5, because we take the coefficients and add them. And then the exponents don't change. So that's one possible confusion that happens during this lesson. And try to show your work so that you can slow down and make sure you do the right thing. Today I'm going to be using a technique, a vocab word called foil. And those letters, F-O-I-L, each stand for a position or word in the polynomial. So the F stands for first, and the L stands for last, and the O stands for outside. And then you can probably guess that the I stands for the inside. And this works particularly nice when we are working with what we call binomials. In other words, two terms times two terms. All right, without further ado, let's get into our first examples of multiplying polynomials. In this case, we're going to start off with a simple idea of multiplying 12 times 12. Now, most of us should know that that is equal to 144, and if not, check that on your calculator, but I'm pretty sure that that's what the value is. I want you to think about that in a different way. That is, don't think about 12 times 12, but rather think about it as 10 plus 2 times 10 plus 2, which in essence is the same thing. Now, when we format it like this, a lot of kids will think, oh, 10 times 10 is 100, and 2 times 2 is 4. So the answer then would be 104. We can clearly see that 104 and 144 are not the same thing, so we've missed something. And what's happened is the kids have multiplied the firsts and the lasts, but they haven't multiplied the outside and the inside. Now, if you multiply those two things together, then we get 20 plus 20 on the inside, 10 times 2 and 10 times 2, and that then gives us the 144 that we know is the right answer. There's many ways to show this. Typically in the old days you might have learned multiplying 12 times 12, kind of like in this fashion, and that's in essence what we're doing here. We take the 2 times each of those, then we take the 1 times each of those, then we write the answers out here, and then we add them up. So that's in essence what we're doing today, only we're doing it in the polynomial world. All right, so let's now look at our first real polynomial, letter B, x plus 2 times x minus 3. First of all, let's go ahead and use that acronym of taking the firsts times the outsides times the insides times the last. You'll notice we end up kind of like with a little smiley face and a chin there and two sets of crossing eyebrows. that may help you to make that face every time. So again, there's the outside, there's the inside, there's the last, so foil, yes? And here we get then the 4 pieces after multiplying them together. X times x is x squared. And the outside is 3 times x, but be careful, there is a negative, so that would give us negative 3x. The inside is 2 times x, so that's just 2x. And then the last is 2 times negative 3, which is negative 6. Now if you answer with x squared plus negative 3x plus 2x plus negative 6, you would get 3 out of 4 points. It's not quite done. We need to simplify. There are certain things that we can combine together. In this case, these 2 pieces can be added together because they both are, remember the apples and oranges? Those 2 things are the same type of thing because they have the same variable with the same exponent. So our final answer for this problem would be x squared plus the negative 3x plus the 2x is a negative 1x. Remember, we add the add the coefficients and the exponents stay the same. And then finally we have the negative 6 at the very end. So there is our answer, x squared plus negative 1x plus negative 6. Again, you could say minus x and minus 6 as well. All right, example C, a little bit more difficult. We could throw in some fractions. We're throwing in some other numbers. And so here we go. Again, if we take the 2n, some people like to take and distribute that 2n times both of those and the 1/2 times both of those. And that works as well. Whatever you can do, just make sure that you get all the pieces. Notice here I have my firsts, I have my outside, here's my inside, and here's my lasts. Okay, so you just got to get all those pieces together, all 4 of them. All right, the first piece here is going to be 2n times n squared. And that gives me 2n to the 3rd power. Remember, we have to add those exponents. Plus. Now I'm going to take the 2n times the negative 3. So 2n times negative 3. And that gives us negative 6n. Always put a plus after that. You'll never make a mistake as long as you keep track of those negative signs. Then I'm going to do my inside, so that would be the 1/2 times the n squared. So negative 1/2 times n squared. And that is just negative 1/2 n squared. And my last is negative 1/2 times negative 3. Whoop. And again, remembering that that's a ratio times a ratio, we multiply 1 times 3 and 2 times 1. Don't forget a negative times a negative is a positive, so we end up with 3/2. Now as we look at this expression here that I've got as an answer so far, there are no terms which are alike. I cannot combine any of these pieces together because they all have different variables with different, they have the same variables but different exponents. So there is my answer. There is nothing to do with it. We can just circle it and move on. I should have, by the way, rewritten this with those 2 terms switched around, because technically you should have the exponent of n squared ahead of the exponent with just 1. Yes? I'm not going to worry about that right now. I'd rather you focus on just getting this done correctly, combine the right terms. Don't worry about the order. All right. Here now we have a trinomial. Notice there's 3 terms times 2 terms. And if you use the idea of FOIL, it kind of falls apart because we don't have necessarily an outside and an inside. There's a lot more. We do have a firsts, we do have a lasts, but then there's a lot of inner and outer pieces here. So it's best to think about this more like a distribution, And so we're going to take the x squared times the x and the x squared times the 5. And then we'll take the 3x times the x and the 3x times the 5. And then finally we'll take the negative 2 times the x times the 5. So that's 6 multiplications that we have to do over here. Again, we'll keep track of them bit by bit. So x squared times x. And that gives me x to the 3rd power plus x squared times 5. So that gives me 5x squared. Okay, so I did the x squared bit. Now I'm going to take the negative 3, yes, times both of the things. So negative 3x times x. That gives me a negative 3x squared. And then the negative 3x times the 5, which is negative 15x. All right, 2 last terms. Take the negative 2. Kind of running out of room here. Negative 2 times x, which is just negative 2x. And then negative 2 times 5, which is negative 10. All right, well, I need to now collect some like terms here. Hopefully you can see some things that are the same. For example, the 5x squared and the 3x squared are alike. So we can combine those two things together. And then hopefully you can see that the negative 15x and the negative 2x are alike. So our final answer here would be x cubed plus negative 15 x squared. Do not change that exponent. There's a strong temptation there. Whoops, I made a mistake. Let me back the boat up. It isn't a negative 15, is it? I made the mistake of multiplying the 5 and the negative 3 because I wasn't thinking. 5 plus negative 3 is 2x squared. Plus, all right, keeping going here, negative 15 plus negative 2 is negative 17x plus negative 10. All right, there is your answer, and you can see how easy it is to make a mistake in the middle of it. So that's why you need to make sure you show your work, kind of look back over your answer to make sure things make sense. Finally, here's an example using maybe a problem. We have a trapezoid, and they say find the area of this trapezoid. And they give us the dimensions of the trapezoid, notice, are all in some sort of variable notation. So the top base is x, the bottom base is x plus 2, and then the height is x minus 7. All right, so here we go, area. 1/2, there's the formula, times the height, which is x minus 7. Now I've got to add the two bases up. X is the top base, the bottom base is x plus 10. Okay, again, I'm getting that from that formula right there. And they will give you the formula. You don't have to memorize that. In geometry class, you will need to know that formula, but right now you can just trust that it is what it is. Now if I multiply, or if I combine that two x's together there before multiplying, I get x plus x, which is 2x plus 10. Now I'm going to multiply those two binomials together, x minus 7 times 2x plus 10 together, and then finally we'll combine the 1/2 into it. Okay? All right. For space, I'm going to come up here. Again, we have the 1/2. And then I've got 4 things I'm multiplying out, yes? X times 2x is 2x squared. Yeah? X times 10 is 10x. Negative 7 times 2x is negative 14x. And negative 7 times 10 is negative 70.
So much so, you may have heard me tell the story before that the Shaw family, when they welcomed Haydn at their door for dinner.
Now I'm going to combine those inner pieces of 10x and 14x together. So that gives me 2x squared plus 10 and negative 14 is negative 4x plus negative 70. And the last thing I want to do now is distribute the 1/2 all the way through there. So what is 1/2 times that, 1/2 times that, and 1/2 times that? And hopefully you know that 1/2 is just dividing by 2, multiplying and dividing by the reciprocal idea. So in this case, we're going to end up with 2x squared becomes 1x squared. The 4x becomes 2x. Forgot a negative sign there. Phew. And then the 70 becomes 35. All right. I guess I don't need the parentheses here on the end. There is my answer. I forgot my exponent on the front here. Wow, lots of little things I'm forgetting as I go through and do those problems. You can see how easy it is to make mistakes. All right, there's the answer, x squared plus negative 2x plus negative 35. All right, doesn't really look like an answer like we used to think about the area of something, but so be it. It is how we get the area given the dimensions in that are in that particular format of x and x minus 7 and x plus 10.